we're continuing with today is least common multiple, finding the least common multiple. And I think we stopped here. I cannot remember. So we did that one, so we're going to pick up here. Finding the least common multiple between these two expressions. 6x squared minus 54 and 9x squared minus 54x plus 81. So the first thing we want to do when finding least common multiple is factor these out as far as they possibly can go. Factor them down completely, and then we're going to look at the factored forms. Now we look at the first one, 6x squared minus 54. We do have two terms, and we need to see if there's a greatest common factor between the two terms, something that can go into 6 and 54. And it turns out that number is 6. So we want to factor that common factor of 6 out. So we divide the 6 out of 6x squared, left with x squared. When we factor the 6 out of 54, 54 divided by 6 is 9. Now from here we need to factor the x squared minus 9. Now interestingly enough, we do have two terms being subtracted, so there's a good chance that it is a difference of perfect squares. And this works as long as, one, there is no middle term, which there's not, and the two terms that we have are being subtracted and can be rewritten as a number times itself, or an expression times itself. Well, x squared is going to be x and x. 9 is 3 and 3. So this is a difference of perfect squares. We'd have x plus 3 and x minus 3. We could actually have x minus 3 and x plus 3. The order does not matter. Questions on how we factor 6x squared minus 54. Now we're going to do almost the exact same thing for the other side. So when we look at 9x squared minus 54x plus 81, is there a greatest common factor amongst these three terms? Well, yes, and it is 9. So we factor 9 out of 9x squared. The 9 factors out completely, and we're left with x squared. When we factor 9 out of 54, 54 divided by 9 would be 6. And we do still have our x. Plus, when we factor 9 out of 81, 81 divided by 9 is 9. Now at this point here, there is no other greatest common factor because 9 was the greatest common factor. And what that leads us to now is factoring the x squared minus 6x plus 9. Now since the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. So our third term is indeed positive, so our signs are the same and match the sign of the middle term. So we'll have negative and negative. Now we're looking at the factors of the first and third terms. Now the factors of x squared, well, the only set we have are x and x. Now the factors of 9, well, we have 1 and 9 or 3 and 3. Most likely for us here, we're going to use or need to have 3 and 3. Now we can check this here and make sure by multiplying out to see what the middle term is. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3x minus 3x, negative 3 minus 3, would indeed be negative 6. So it tells us that those are the correct factors. Questions on this here? Questions on anything we've done so far before we start finding the least common multiple? Now, the first thing we need to find the least common multiple, or one of them, is 6 and 9. We want to find the first number we can turn both 6 and 9 into. So again, there's different ways we can do it. One is kind of, I think, the longer method. 6, 12, 18, 24, 30, 36. I just list out all the multiples of 6, and hopefully I list far enough out that we have something in common. Then I can do the same for 9. 9, 18, 27, well, 18 is the first number that we have in common. The other way to do this is with our factored forms. If we look at the factors of 6, or the factorization of 6, 6 is 2 times 3. That's in prime factorization. That's as far as it goes. 9's factored form is 3 times 3. And when we look at the least common multiple between these two here, using this factored form, we look at which one has the most factors of each factor. So we look at 6. 6 has a factor of 2. 9 has 0 factors of 2. So the most factors of 2 that shows up as a factor with either number is 1 factor of 2. So we list it once. Then we go to 3. 6 does indeed have 1 factor of 3, but 9 has 2. And since 9 has more factors of 3, we're going to need it twice. And at this point here, we multiply these three numbers together. 2 times 3 is 6. 6 times 3 is 18. So the least common multiple between 6 and 9 is 18. Questions on how we found 18? Now, I think, especially once we get in factored form, the parentheses are a little bit nicer. Because when I look at the parentheses, we'll start with, say, x plus 3. Our expression on the left has how many x plus 3s? 1, yes? How many does the one on the right have? 0. So x plus 3 shows up at most once in either one, yes? So the most times it shows up is 1, which means for our least common multiple, we need it once. Now we're going to look at x minus 3. How many does the one on the left have? 1. How many does the one on the right have? 2. Which one has the most? The one on the right, yes? And it has? So how many times does it need to be listed in the least common multiple? 2 times. Even though it does show up 1 time on the left, 2 times on the right, the most it shows up out of either one is twice. Because we're looking for the first expression that we can make them both be the same. Since one of them has 2, we need it twice. We don't need it a third time because it only shows up twice in one of them. If it showed up 3 times in one, we need it 3 times. Because at this point, if we want to get them to be the same, figure this out. Third time's the charm. Because again, this is the goal. For us to be able to add or subtract, we need the denominators to be the same. So if these were the denominators, we need them to become this here. Now to do that, we would multiply the left side by, well, 3 to be able to get the 6 to be 18. And it is, we do have the 1x plus 3. We're good there. We have 1x minus 3, but I'm missing a second x minus 3. So if I multiply the one on the left by 3 times x minus 3, it would be the least common denominator. We would get them to be the same. Now the one on the left, or the one on the right, we would multiply this. I'm going to multiply it below it because I don't have room to the left or right. Well, I need to get the 9 to be 18, and to do that I have to multiply it by 2. Now it does have both of the x minus 3's already, so we're good there, but what is it missing? The x plus 3. So if I multiply it by 2 times x plus 3, They are now both the same, and they are both that least common denominator. Questions on this here? Because the least common denominator is just the expression we need to have so that they would be the same. The first expression that would make them be the same. There are others that could work, but those add other factors. Let's look at one more of these here. Five x cubed and 10x squared minus 15x. One of these is really nice. 5x cubed. 5x cubed is already factored, it's already simplified, nothing we can do with it. 10x squared minus 15x. We don't have a constant term, so most likely we're not going to have two sets of parentheses with three spaces. We can't go through that. But is there a greatest common factor between 10x squared and 15x? 5 and x. Because if we factor 5x out of 10x squared, 10 divided by 5 is 2. And if we factor 1x out of x squared, we get x minus. If we factor 5 out of 15, 15 divided by 5 is 3, and the x factors out completely. Least common multiple. It doesn't matter where we start when listing the least common multiple. I can start with our coefficients, the numbers that are just by themselves, or I can start with the parentheses. Now, if I start with the parentheses, we only have one set in either one, yes? And it is what? 2x minus 3. It shows up in one of them, so we need it. Now we need to find the greatest common, or our least common multiple between 5x cubed and 5x. Well, the first number that I can turn both 5 and 5 into is 5, is the number itself. Doesn't mean we have to go up. It can be just 5. Now, they also do both have the variable x, yes? Now, the one on the right, how many x's do we have outside the parentheses? 1. The one on the left, how many do we have? 3. So how many do we need? 3. That's it. Questions on this here? So the whole goal, least common multiple, and they'll call it least common denominator also, is figuring out what expression we need to get them to be the same. Now, for the most part, once we get an understanding of how we do this, we're not necessarily going to write out what it is every single time for every single problem. It's helping us to see what we need those expressions to be, in this case, what we need to do to 9x squared and 3x squared plus 3x to get them to be the same. Now, the first thing we're going to want to do is factor these denominators as far as possible to help us figure out if there's anything in common to multiply together, or figure out what we need to do to get them to be the same. Now, 9x squared is as simplified as it gets. Single term, nothing we can do to it. Now, the 3x squared plus 3x, there's a greatest common factor of 3x. And if we factor the 3x out of 3x squared, the 3 factors out completely, and our x squared is going to become x. Plus, when we factor 3x out of 3x, it factors out completely, giving us just plus 1. Now, both of those are factored out completely. And we can use both of those to find the least common denominator. It's just least common multiple, but we say denominator because we're referring to the bottoms of the fraction. So what we need to find the least common multiple and least common denominator is the exact same thing. It's just least common denominator is talking about the expressions on the bottom of the fraction. So the two we're looking at is 9x squared and 3x times x plus 1. 3x has x plus 1 listed once. So for these two to be the same, the least common denominator, x plus 1 has to be in both. And it only shows up once in one of them, so it's only going to be needed once in both. So they're only going to need it once. Then we're going to look at our constant terms, these terms outside of the parentheses. So we're also trying to make 9x squared and 3x be the same. Well, we can look at the variables first. The one on the left has x squared, it has two of them. The one on the right has one. So x is going to be listed a part of our least common multiple, least common denominator, because x is in both. But how many x's do we actually need? 2, because it shows up 2 times. Is the most it shows up in either denominator. And lastly, we need to figure out what is the first number we can turn both 3 and 9 into. And we can look at the least common multiple of 3 and 9. Well, 3 is prime. And 9, if we write it as its prime factorization, would be 3 times 3. 3 has 1 3, 9 has 2 3s, so the number of 3s we need for the least common multiple is 2 of them, or, well, 3 times 3 is. Questions on this here. Now what that's telling us is for us to be able to add or subtract these two fractions, these two rational expressions together, is we need the denominators to be this expression 9x squared times x plus 1. Because if we can get both of them to be 9x squared times x plus 1, the denominators are the same, and we can add or subtract, in this case, add the numerators together. Now to do that, we're going to multiply both of them by 1. So if we start with the one on the left, the denominator already has the 9x squared. What it's missing is the x plus 1. So what we're going to do is multiply the top and bottom of this fraction by x plus 1. Now the main reason we can do this is because x plus 1 divided by x plus 1, anything divided by itself is 1. Now on the right hand side, we're going to do a similar thing, but I'm not going to multiply the top and bottom by x plus 1 because it already has it. The main part we need to change here is we need to change it from 3x to 9x squared. So what times 3 is 9? 3. So we'll have to multiply the top and bottom by 3. Now what times x is x squared? X. So the piece that the right one was missing to get to the least common denominator is 3. So we multiply the denominators. X plus 1 times 9x squared is going to be 9x squared times x plus 1. There's no reason to multiply through and actually distribute it out, because if there's something in common on top and bottom, especially at the end, we need it to be factored. And the nice thing with addition subtraction is once the denominators are the same, we add or subtract the numerators, and the denominator just becomes that expression. We aren't having to combine like terms on the bottoms of the fractions. It just is this expression. So there's not a whole lot of reason for us to multiply 9x squared by x and 9x squared by 1. Because if there's something in common, especially with, say, the 9x squared or the x plus 1, we'd have to factor it right back out. Now, on top, we will have to add the numerators. We're going to have to combine those. So at this point here, especially since we have a single term being multiplied through, we can go on and multiply it out. 7 times x is 7x. 7 times 1 is plus 7. And 3x times x is going to be 3x squared. And since the denominators are the same, we can go on and add our numerators. Now, yes, at this point, we don't necessarily need the parentheses because it is addition and the second term is only one term. But it is not wrong to have them. Now, at this point here, we can simplify, we can resolve the parentheses on top. 7x plus 7 is still going to stay 7x plus 7. And 3x squared is still going to stay positive. So really, it's just we drop the parentheses as we resolve that there. Now, it might be helpful to have this in standard form to see if something factors, if something reduces. So standard form is going to be 3x squared plus 7x plus 7. Now, for the most part, this has a feeling it might not factor. There might not be factors of 3 and factors of 7 that get us to 7. And we can double check that and make sure, because if I want to double check and make sure this doesn't factor, we have this part of the quadratic formula, the square root of b squared minus 4ac. This works in telling us if there are factors, if, 1, this does not give me a decimal number, or 2, especially in the 30xs, our scientific calculator, it does not give me a domain error. It does not tell me that what's inside the radical is negative. So if I take this here and go second square root, b is positive 7, so we have 7 squared, minus 4 times a is 3 times c is 7. It tells me domain error, which means if I go and remove the radical, we're looking at the square root of negative 35, which would be I square roots of 35, which tells me that the numerator does not factor. So this is actually as simplified as it gets. If it did factor, we need to factor it. Because if there's a common term on top and bottom, there's a common expression on top and bottom, we need to reduce it out, we need to simplify it. Questions on this here? Let's look at the next one. 8 over 12x squared plus x over x squared plus x. We need to factor the denominators as far as possible. Now, there is a greatest common factor between 8 and 12, and we could simplify that, and it would work out for this here. And I would do that as long as I know that whatever I'm simplifying out doesn't need to be added back in so that the denominators are the same. Now, if we look at the one on the right, x squared plus x, if we're factoring it, we have a greatest common factor of x. So we had x times x plus 1. On the left-hand side, 12x squared, well, that is just 12x squared. Now we need to find the least common denominator. Really, all this is telling us is what do both of them need to be on bottom so that they are the same. Well, we do have x plus 1 on the right. The left does not have it, so eventually we're going to need to what? Multiply the left one by x plus 1 over x plus 1. That's just minimum for them to be the same, yes? Is there anything else that the one on the right has that the one on the left doesn't? Well, the only other thing on the right is the x on bottom, yes? The one on the left has an x. It actually has not just one of them, but it has 2. So really, the one on the left now has everything the one on the right has. Let's go the other direction. If I look at the one on the left, it has the 12x squared. We also gave it the x plus 1, so we're good there. is there anything it has that the one on the right doesn't have? 12, for sure, which means our least common denominator would need a 12. And it has x squared. It has two of them. The one on the right only has 1. So we'd also need to multiply it by x over x, telling us that the least common denominator is 12x squared times x plus 1. So now we just need to multiply. On bottom, x plus 1 times 12x squared will be just what? 12x squared times x plus 1. And really, the denominators, as long as we're not having to add anything, which for the most part we won't unless it's just two expressions that need to be simplified. On the other side, our x times 12x. The 12 is fine. X times x is x squared, and it's being multiplied by x plus 1. Questions on this here? The numerators we're going to have to multiply through because we will need to combine like terms if there are like terms. 8 times x is 8x. 8 times 1 is plus 8. On the other side, x times 12x is 12x squared. Now we can add these two together. So we'd have our 8x plus 8, and we're going to add 2 at 12x squared. And it's all over 12x squared times x plus 1. Now again, at this point, it might be tempting we can't do it. We can't just cross out the 12x and 12x squared. Because the two numbers on top, the two expressions on top are being added together. They're stuck together. Now at this point, we can resolve the parentheses on top. Since there's no sign or number in front of the parentheses with 8x plus 8, they're going to resolve. It's still going to stay 8x plus 8. Plus 12x squared, we can reduce or resolve those parentheses, giving us plus 12x squared. Now I'm going to write it in standard form so we can see if we can reduce. Is there a greatest common factor amongst the top three terms? 4. So if I factor 4 out of 12x squared, we get 3x squared. If I factor it out of the 8x, we get 2x. Factor out of 8, we get 2. Oh, wait. Now we do have something in common on top and bottom, something we can reduce, yes? And the reason we can is that 4 out front is being multiplied with that entire expression, which means the 4 on top and the 12 on bottom can reduce. And when we do that, the 4 on top is going to reduce completely to 1. The 12 is going to become 3. Now the question is 3x squared plus 2x plus 2 factor. I don't know about y'all. I have feelings that it doesn't because, as we know with this here, since we are adding whatever the common or those two middle terms are, we're going to have to add them together. So we're most likely going to be multiplying the 3 and 2 to get 6 plus 1 for the other factors. It gives us 7. Or 3 plus 2. 3 times 1 is 3. 2 times 1 is 2, giving us 5. Still bigger than our 2. And I can double check and say square root of positive 2 squared minus 4 times 3 times 2. Again, no made error. Wrong notes. And again, we can't cross out the 3x squared and 3x squared because the 3x squared on top is stuck with the plus 2x plus 2. Questions on this here? So could we have actually simplified this common factor of 4? Well, yeah, because there was no necessarily need for the 4 in the other spot. However, if I simplified this x out on top and bottom, if we actually went those simplify out, I'm now not multiplying by 12x, we're multiplying by 12x squared to get them to be the same. So here we needed the x and x. Well, not necessarily we needed it. If we didn't have it, we had to change what we're multiplying to get it to have it again. However, over here with the 12 and 8, if I reduce this to 2/3, there is no number over here with x to offset or that we need to set it to. So we really just be changing this to 3 and 3. Kind of makes sense. But if we're not sure if we need it, if we don't need it, if it would reduce, would cause errors, just leave it. But we will